Hey guys, Doc Brown here. I'm here to show you guys kind of what we did on Monday. I'm doing this after class is over. I'm gonna try and make the videos for tomorrow and Thursday as well, right after this. So bear with me as we go through it. This way, if you guys missed the class or if you guys want to do it ahead of time, you guys can just watch the video and then update your notebooks when it's ready. So when I'm looking at my notebook, you guys should have gotten the week two. It'll say student copy, not master copy. A couple of things, make sure your name is on it, your period, whichever period you're in. This is going to be week two. I did add a new reference. Well, it has a lot of the old stuff on it, but I did add a couple of extra posters on there. And then I added this extra one right here just so that you guys can get an idea of what my word wall would normally be. So it would be in the back of the room. And it just gives you guys basic ideas of like, PEMDAS, this is how you do it, multiplying and dividing, different properties. So do you have to do anything with this? No. This is just so that you guys have a visual of some of the activities or the topics that we're going to be covering in class for this unit. So this is your reference. We are actually going to start Monday. This is August 28th. We're going to be starting today. Woo, I decided to go crazy. We're going to start with slide 3. And what you're going to do is you're going to drag pieces over until all of these pieces on the right side are all done. And they're all on the page. You know that you're done 100% when everything has moved over. And you are just following along to what I have here. So moving forward, intro to algebra. So the first, we're going to be covering how to identify different parts of an expression. So the first thing that we should talk about is terms. So terms are separated by operations. So that means that this piece right here and this piece right here are going to be separating our pieces in our expression or our terms. So we can count. We have 1, 2, 3 terms, and we know that because it's being separated by the subtraction and this addition. So we know we have 3 terms. All right, so you should go over to your notebook. Look for where it says separated. It might be behind me. Oh, it's right there. I didn't see that. And then I'm going to drag this over. And then I have those 3. So I'm going to drag this. I'm going to drag this. I'm going to drag this. And then the 3 terms. I'm going to drag that. And you're just going to continue to do that. I'm not going to do the rest, but all you have to do is the exact same thing that I did on this slide. You guys are going to do in your notebook. So the rest of the video is just me explaining the rest of the notes so that you guys can pause, go back, re-listen, however you guys need to do your notes. The next part that we're going to talk about is variables. When it comes to variables, you are the pieces that we don't know. So whenever we're doing like a word problem, we might use a variable to replace something that we don't know. So like if we're talking about apples, then how many apples is in this bag? We don't know. So X would represent the apples. You don't normally have to use an X. Most people tend to use an X. Another very common variable is Y or N as in Nancy. So it doesn't matter. It could be a smiley face. It could be a box. So you guys, when you were in elementary school, you used to do it with a box. So it just does, it doesn't matter which one you use. In this example, we do have 2 X's. So those would be our variables. For just make sure that you do pay attention to a preference that your teacher might have. So some teachers might want all of your variables to be X's or all of them to be N's or all of them to be their initial. Just be mindful of what your teacher is looking for. All right. The next thing, actually, I'm going to try and hide that so that you guys can see the bottom. All right, the next part that we're going to be talking about is coefficients. So what's a coefficient? That's the number in front of my variables. So that's this guy right here. That's the -5, and then the 4. It is not the 6 because the 6 does not have a variable with it. So which coefficients do we have? We have a 4 and we have the -5. Realize that I said -5. So you need to pay attention to whatever sign is up in the front. So in this case, we do have a subtraction symbol. So this actually turns it into a -5 versus subtract 5. So whenever you see subtracting by something, that something will be negative. All right, so that subtraction symbol just means that it's negative. So pay attention to the sign that you have. And then the last vocab that we're going to be talking about is called constants. So what's a constant? A constant is a number that's by itself with no variable and never changes. So what do I mean by never changes? Well, whatever the value of x is, if I plug in, let's say, a 4, then I can do -5 times 4. Now this term turns into a -20. So now it changed. But I can't do anything to this 6 to make it into a different number other than 6. So that's why it's called a constant, because it will stay the same no matter what. All right, so again, it's a 6. Pay attention to the sign, just like we said before, because whatever sign it has, it is connected to the number. So if this was a negative, it would have been a -6. All right. So here's an example for you guys. I want you guys to kind of try and pause it right here and see if you guys could do this on your own. If not, then you can just keep going. I'm going to pause for 3, 2, 1. Hopefully you were able to do part of this. And you're just reviewing it at this point. So it says give the term, variable, a coefficient, and constant. So how many terms are there? There are 1, 2, 3, 4. So the number of terms is 4. What are the variables? So I'm going to look all my variables, and that would be x and a y. What are my coefficients? That's the number in front of the x and y. So that would be 4 and 6. And one numbers are constant, meaning that they don't have a variable, and that's -7 and 5. So that's the vocabulary that we kind of need to keep in mind whenever we're dealing with math, especially with equations, because it makes life a little bit easier when you guys understand the vocabulary that we're dealing with. In this part, we are now on your next note page. So, we are on slide 5 in your notes. So, the only difference with this is that I didn't actually type in every answer over here in the corner. So what you're going to have to do is you're going to have to double click in here, and then where it says fill, you guys will type in the answers that I have here in the yellow. All right, so what is combining like terms? Combining like terms is a process used to simplify expressions by adding or subtracting similar terms. So try this on your own. You want to see if each one of these, so these two, these two, these two, and these two, would be combined or not. So, write a yes or a no right underneath it. So 3x and 8x. Both of them have an x, but their numbers, the coefficients in the front are different. It doesn't matter about the coefficient. We only care about the variable. So since both the variables are the same, this is going to be a yes. On the next question, we look and we have a -4x and a 2y. Since we have two different variables, this is going to be a no. It has to have the same variable no matter what. For the third problem, I want you guys to make a guess before I say it. All right. So again, on the count of 3, say yes or no. 1, 2, 3. So the answer is actually no. The reason why we have this variable right here, what the variable means is that we have two x's. since we have two x's and the other one only has one, that doesn't match up. They have to have the same amount of x's. So since it doesn't, then it's going to be a no. And the last one, I have a negative 5y and a negative y. Both of them have a y, so then this is a yes. In the next problem, I am making it so that it made it a little bit easier where all your like terms are grouped together by like putting the same colors down. So all we have to do is just add or subtract depending on the signs that I have. So I have 3xy minus 5xy. 3 minus 5 gives me a negative 2, and I just bring the xy down. For green, I have a negative 2x and I have a positive 9x. Negative 2 plus 9, that's just the same as 9 minus 2. That's a 7x. Now, the y is interesting. It does not have any other pair to it. So all I'm going to do is just bring it down. I don't have to do absolutely anything to it. And the last part, 14 minus 8. 14 minus 8 is 6. And the very last part is to put them all together into just one spot. Okay. Now, underneath in the same page, you're going to do this part. Now, this part, you actually are dragging everything over to the side. So, simplifying expressions, what does that mean? It means you're going to be combining like terms. Well, what are like terms? Like terms have the same variable with the same power. Again, this is the reason why we needed to make sure that we have the same power on both sides. So let's talk about different examples of which ones I could combine and then which ones I can't. So 7x and negative 3x. Both of them have an x, so then yes, I can combine them. However, if I had an x and a y, then I wouldn't be able to. On the other, we have an x and a y, and this one has a y and an x. So even though the order of both of them are different, it doesn't matter. It just means that I probably got lazy. I wasn't paying attention. But I can still combine them because I have one x and one y on both of them. However, on the other one, I have one that has an A, and then the other one has an A and a B. Since it hasn't, like this one's missing a B, then we wouldn't be able to add these two because it's missing a variable. Oops. In this one, again, it's all about order. I have two A's, I have a B, I have a B, I have two A's. So I can still add these up. However, if I look at the other one, the X is the one that's doubled. But in this one, the y is the one that's doubled. So I can't have two x's here and only one x here, and one y and then two y's here. So this is why that's a no. So we're going to go to the next page. And all we're doing in this page is that we're going to combine like terms. So I'm going to look and see that I have x squared and x squared. So I'm going to put both of those together. And then I have an x and an x. I'm going to put both of those together. So all I'm doing is just grouping them apart so that I can just make sure that I don't forget one of them by accident. So then I just add or subtract like normal. 1 minus 6 gives me, 1 minus 7 gives me a negative 6. I'm already doing it in my head. And then 3 minus 1 is a positive 2. Since this has two x's and this only has one, then my answer is that. Now the next one, we have multiple x's. So we actually have three x's this time versus just the two. And then I have my two constants, so I'm going to put those at the end. So I'm going to add 2 minus 2, and then I borrowed another 5. So my answer is going to be negative 5x. And then 4 minus 3 is just 1. Again, I can't add them up because they both don't have an x, so then I just leave it like that. All right. For this one, I am going to show you guys all the question, but then I'm going to break it apart so that you guys can focus on just the parts that I need you guys to focus on as we're moving forward. So for instance, in this one, if you think order of operation, I have to do parentheses first. So I'm going to get rid of everything else while I'm doing this. And then you guys are going to see, okay, well, I have a subtraction. Well, why did that subtraction stay there? Because technically there's an invisible one in between the subtraction and the parentheses. So don't forget that part. A lot of people tend to see the subtraction symbol and then just erase it. And then they're like, oh, it's done. I don't need to worry about it. But in reality, you need to still distribute it. So I have a negative 1 times x gives me a negative 1x. And negative 1 times 2 gives me a negative 2. That's done. I can bring everything back that I took away so that I can focus on it. And at this point, I can combine like terms. So I have my two x's. So I have negative 1x plus 3x. So that gives me 2x. And then 4 minus 2 just gives me 2. Again, even though I have a 2 and a 2, I can't combine these two guys because this 2 doesn't have an x. So I'm just going to leave it like that. And the last one, I have two pieces. So I have this piece right here and this piece right here. So I'm going to erase the one in the back and I will bring it back later. So I'm going to do 5 times x. 5 times x gives me a 5x. And then 5 times 2 gives me 10. Again, I can't combine them because the 10 doesn't have an x. So I'm going to worry about the next one. And I'm going to remember that this subtraction actually goes with the 4. So this is negative 4 times x gives me a negative 4x. And a negative times a negative gives me a positive. 4 times 6 gives me 16. And now I can combine like terms. 5x minus 4x gives me 1x. And then 10 plus 16 gives me 26. And there we go. Now I know in your notebook you have 2 other pages. Actually, I changed my mind and I'm not going to do the rest of them because we did go over distributive property right here. So I didn't feel the need that we needed extras. However, if you look at my PowerPoint presentation, it's still there. So if you want to be able to see those presentations, you guys can always look at it on there. But other than that, that's it for me. So let me know if you guys need anything, and I'll see you guys later. Oh my God. Thank you.